Dear student, in this lecture we are going to learn about computer network, and our topic is multiple access protocol and unit link layer. As we are discussed in our previous lecture about multiple access protocol and its type, now we are moving on CSMACT energy level and throughput. Through this energy level we can find out about the collision and in the whole process. So when the zero level is occur of energy, that time channel is in ideal condition, and when the energy level is normal, that time channel sending its frame and its success, because it successfully capture station has successfully captured the channel, so it's send the frame. At the abnormal time there is a collision and the level of energy is twice the normal level. So the throughput of CSMACD is greater than the that of LOHA, and the maximum throughput occur at the different value of G is based on the persistence method. If the persistence if the maximum throughput is 50% when G is equals to 1, and when G is equals to 3 to 8, then persistent, or we can say throughput is equals to 90% here. This is the graph through which we can understand about energy level and collision. See, when the transmission is occur or frame will transmit it, that time energy level is equals to normal level, and when no frame transmitted, that time energy level is zero, and energy level is just double, or we can say it's abnormal level when collision is occur in the station. Now we are moving on CSMACA. CSMACA is collision avoidance. See, in this process how it works. A station When a station wishing to transmit, it sends the medium first, and if the medium is busy, then the station defers its transmission to a later time. And even if the channel is found ideal and no activity is detected, the station wait for a period of time called interframe space. This is interframe space, IFS. And the IFS time allows the front of transmitted signal by the distant station to reach this station. If after the IFS time the channel is still found at an ideal, then the station waits an additional randomly selected amount of time called connection window. See, there is a connection window here, and the connection window contain time slot 2. Wait, the number of these time slot changes according to binary exponential back of energy, and the station now transmit if the medium is still free. If the packet is received intake, the receiving station issue an acknowledgement frame, and that once successfully received by sender and complete the process. So this is all about how it will be worked. Now we are moving on token passing. So what is token passing? In token passing, whenever the network is unoccupied, it circulate a simple 3 byte token, and this token is passed from NIC to NIC in a sequence until it's encounter a station with data to send, and that station waits for the token to enter its network board, and if the token is free, the station may then send a data frame, and it captures the token and set a bit inside its neck as a reminder that it has done. So then send one data frame. This data frame proceed around the ring, and each intermediate station examine the destination address and find that the frame is addressed to another station and relays it to its neighbor, and the intended reception recognizes its own address and copies the message, checks for error, and changes 4 bit in the last byte of the frame to indicate address recognized and frame copied, and the full packet is then continuous around the ring until it returns to the station that sent it. So the sender receives the frame and recognizes itself in the source address field. It then examines the address recognized bit. If they are set, it knows the frame was received, and the sender then discarded the used data frames and release the token back to the ring. So this is the process through which token passing worked. See, this is a physical ring, this is dual ring, this is bus ring, and this is star ring. These kind of um, networks we are using in token passing. Now we are moving on channelization. In channelization, there are three technique: FDMA, TDMA, and third one is CDMA. So first we are uh, learn about FDMA. So in FDMA, available bandwidth of the common channel is divided into bands that are separated by a guard band. And FDMA is an access method in data link layer protocol, but FDMA is a physical layer technique. In this, frequency band is divided. Now we are moving on TDMA. In TDMA, bandwidth is just one channel, that is time shared between different stations. Here we are divide the time slot, not frequency. So each station need to know that the beginning of slot and location of its slot. This may be difficult because of propagation delay introduced in the system if the stations are separate over a large area. See, here we are divided time, not frequency. Now we are moving on CDMA. This is last generalization protocol. In this, one channel carries all transmissions simultaneously. Two property here. If we multiply each code by another, we get 0. If we multiply each code by itself, we get 4. So data is DC1 plus DC2 plus DC3 plus D4C4 is equals to 4D1, and each sequence is made up of n elements, where n is the number of stations. I hope you understand these all things very well. Thank you so much.